So today I wasn't sure if I was going to be here because I was in the elevator in the hotel, and the elevator stopped abruptly and lurched, and it was terrifying. And I went back and they said, this elevator is dangerous and it's been closed, and I presume that's what it said because the sign was in Polish. So. Anyway, it's great to be back in front of you. It's a joy to actually speak in Poland, a country that we all have a great debt of gratitude for because so you have José Valim, of course, the creator of the Elixir on which this talk is based. But I want you to think about this talk not as a journey to Elixir, but as the typical type of climb that most open source frameworks have to make to be successful. Every single person in this room has been enriched and enabled in some way by somebody in open source. So I want to think about those communities, and I want to tell you a story, not from the actual developer of the language itself, but from maybe someone from inside the team that had visibility into the process. And let me start by saying that we are blessed. We are alive in a time when things are changing radically, when tremendously exciting things are happening all the way across our industry, from programming languages to designs and architectures. I can talk to my phone. I can see a map with a point exactly where I am right now. That map can navigate me to another place. It's an exciting time. But I want to talk about, in particular, another exciting concept, the concept that somebody in Poland can make ripples that spread around the world with a programming language called Elixir. I think that stories make up our DNA. We are the combination of all the stories that we participate in. And I wanted to start to tell the story to the Elixir community. And then as I got some feedback on the talk, I wanted to tell this story more broadly because I think that it's really not our story anymore. It belongs to the rest of the world as well. So to get this started, I'm going to tell you a little bit about my story, not because I'm special, but because it really helps lay the foundation for some of the things that happened. And it shows you the lens through which I view the world. If you saw the keynote, you saw my first computer. This is not my actual first computer, but it's one like it. And you heard the story of how we took the memory chips and we soldered one on top of the other to add more memory. It was a little bit harder back then. So on this computer, I learned what a byte was. I learned that with peek and poke, these are statements in BASIC. You could actually shove a number into memory, and if you picked the memory that represented what was on the screen, you could actually light up a bar. And I learned that 128 lit up a point all the way on the left, and 1 lit up a light all the way on the right. So I learned what a byte was at a pretty young age as a developer. This was a pretty interesting endeavor for me, and I was from the South of the United States, but I had no tan. I was white because I was always sitting in front of this computer. And then I got into high school, and they weren't so lucky. They had the black and white version of this computer. And I had a lot of great times on this one as well. I even got into a little bit of trouble. The school board was involved, and there was a burning Santa. And it wasn't a pretty picture. We were asked to make Christmas cards, and mine got a little bit too radical. But I learned to really love BASIC. I know that that's not the most macho thing to say at a programming conference, that I love BASIC, but I really did. I had an affinity with BASIC. But all good things had to come to an end, and my high school career came to an end. And I went to college first at a school called Mississippi State. Later, I did my master's work at the University of Texas. And in Mississippi State, I wrote mostly Pascal, but I also wrote some C and a little bit of Lisp. I liked Pascal pretty well. I did pretty well with the language. I got to love programming contests, and I did well because I would typically, rather than try to solve the problem, I would try to iterate through all the result sets and back into the answers that way. I'm a little bit messed up that way. And during this time, the IBM computer came out. I couldn't afford one of those. I got a clone. But it was interesting because when high school was over, I went to work at IBM, and I got to play with a whole lab full of IBM, the original PCs, and XTs and ATs, and I got to trade in my cassette tape recorder, for persistence, and we got to use floppy disks, and later the 10K hard drive, which was great. And there was a 10 meg hard drive that came out after that, which was even better. And at IBM, I learned to love languages a little bit. I got to use C and C++ and Java. Now, I've got to say, none of these languages really clicked for me. How many of you saw the talk before on the techniques with the JIT? Fantastic talk by Douglas. And he said, this is not black magic. Well, I was watching the talk, and to me, it's black magic. I've got to say, Java never really clicked for me, but I tolerated Java. I learned to love languages, but I only tolerated Java. And all good things must come to an end. I left IBM, and this was the time when everybody was making, blah.com, and they were all starting these businesses, and you could do anything. I mean, you could make an application for your dog, and some venture capitalist would throw a couple of million at you, and you could hire your best friends and basically ride off into the sunset and live happily ever after. So it was 1999. I left IBM to join a startup, one called All My Stuff, later called Bravado Systems. And it immediately blew up. I mean, it was 4 months, and that startup blew up. But I learned to think for myself, and I learned how to program when programming really meant it, when it meant the difference between life and death. And I started to develop more of a love-hate relationship with Java, and I started to write. And in fact, you could see my love-hate relationship in two of my first books, Better and Bitter. The book on the left-hand side, that's Bitter Java, and it did really, really well. And it did well not because it was a great book, but because there were people that loved Java, and they were kind of getting all the play and all the press, and there were people that really didn't like Java. And people saw that title, and then they started to assume that the book was about something that it wasn't. That Java, that this was finally somebody coming out and saying Java's evil. And so we actually had Amazon at this time. And at Amazon, they ranked books. And maybe there were a couple of million books on Amazon at that time. And I loaded the page, and I was number like 1,200,000 something. I said, hey, that's pretty cool. I have a ranking. People are buying my books on Amazon. And then I hit reload, and it was in the hundreds of thousands. And I said, wow, this is cool. More than one person is buying my book on Amazon. What does that mean? I've sold like 2 books or something? And then my wife and I started clicking reload, and this thing started getting higher and higher. And a site called the serverside.com found Bitter Java, and started to post about it. Nobody was actually picking up on what the book was really about. They were assuming what it was about, and there were a lot of essays that were way better than the book. But in the meantime, the book kept creeping up, and till eventually it got Slashdotted. You remember Slashdot? It was where all the programmers went to play. But when the programmers found it, they said, hey, we're going to organize this buying thing where we're all going to buy Bitter Java at the same time. And so for 1 hour, I had a book on Amazon that was between 6 and 8. between Grisham and Hawkins, Bruce Tate up there with a really bad book, right? And that's how my speaker career started. And so I did Java for a while. I did some Java consulting and enjoyed the process tremendously and started to refine my craft in speaking. I still don't consider myself a great speaker, but I'm a lot better than I was back then. And there was a man named Dave Thomas who actually owns the publishing company that I work with now. And he actually shook me up a little bit. We were on a train from the Atlanta suburbs back to the Atlanta airport. And Dave looked at me and he said, Java is not really everything that you say it is. And it kind of knocked me out of my chair for a little bit. And I was brooding and reflective. And about 10 minutes later, I looked up again and I said, "What do you mean?" And then he brought out his laptop and he started showing me a little bit about the Ruby programming language. Now, as a consultant who was really, all I was doing was building one application after another that was just a big fat web user interface that was babysitting a relational database. That's it. Didn't have to be fast, didn't have to be pretty, but Java was doing okay at that. And Dave built one of those applications in about 3 minutes. I said, oh man. And then now I'm going to take him apart. And I started asking him things about, performance and scalability. And he said, well, this can all be cached. So this will run as fast as your Java stuff did. And with that conversation, Dave wrecked my Java career. So I came back at him and I said, surely it can't do this, surely it can't do this, surely it can't do this. And this polite British gentleman said the only impolite thing that I've ever heard him say. He said, "Shut up, do something non-trivial in Ruby, and then come back and we can talk." And I did. And I actually got a friend to do a commercial product in Ruby, and really never looked back. So I wrote this book because nobody was actually using Ruby in the United States yet. And I wanted to say that, if you're going to do this, this is how you should do it. And these are some things that you should know. Now, it never sold in the United States because by the time the book was finished, everybody and their mother was building a startup, and it was primarily powered by Ruby on Rails. But the book did really well in Japan, where people were more risk averse. So one of the things that I learned at that time was that Dave has an incredible eye for programming languages. He has strong opinions. They may not be your opinions, but they're strong opinions. And he could recognize when a language had that special something that would make it click with a broader audience. He wrote a book called the Pickaxe book, but what I really want to talk about with Dave is his eye, his recognition for a concept called QWAN. Now, he turned me onto a book called The Timeless Way of Building. This book wasn't about writing software at all, but it was about building buildings. And the author, Christopher Alexander, had this to say: "There's a central quality which is the root criterion of life and the spirit in a man, a town, a building, or a wilderness. This quality is objective and precise, but it can't be named." And so programmers started talking about this concept, and Dave had an incredibly gifted eye, an ear for the quality without a name. We came to call that concept QWAN. It says Dave, I can't name it, but I know it when I see it. So Dave, over and over in his career, has used this ear, this eye, this nose for great languages. But the one that captured people's imaginations first was the Ruby programming language. Dave wrote the Pickaxe book after spending time with Matz, the creator of the language, and he was able to convince people that this was really something special. So Ruby had these cool things that weren't available in the languages that I was using at the time. This idea that during the compilation, or really the class definition time, you could do things like run code. And that opened the world to allow us to do things like, rather than define a function, we could build a route table with a domain-specific language. And that domain-specific language could even return something randomly. And I could do things like open up a class. Here I'm opening up nil in the string class, and I'm declaring the same method, blank, question mark. And so that anything in the language, I could say thing.blank, and it would return a simple true or false. So Dave said Ruby is a beautiful thing, and I agree with him, and built a consultancy around that. And really had a good time with Ruby. I still had a lot of friends in the Java space. I still connected with that space. I was even a Java champion during that time. But eventually, I came to see that programming languages were changing, and that some of the decisions made for the object-oriented family of languages, including Java and Ruby, were going to be limiting when the next family of languages was going to be adopted. And that some of the decisions that we made when we were building hardware made functional programming much more valuable, that made mutability much less valuable. And I came to see that even though Java is not inherently mutable, the way that we were using it, the way that we were teaching it was. And that concurrency managed with threads and locks couldn't be the way that the whole world went forward. So I went way back on the shelf of my brain, and I pulled out this concept that Dave gave me, and when he said, shut up, do something non-trivial with Ruby, and then come back to me. My experience with Ruby was so strong that I decided to apply that to one of the functional languages, but then I asked myself, which language should I apply it to? I became really afraid, irritable, moody. My wife would tell you that nobody liked me during that time. But as I was going through that experience, I thought that maybe I could do something non-trivial in more than one language, and maybe I could carry my readers along with me. And maybe I would learn a language for about a month, and then I would build a set of exercises that people could use and do that process in about a week. And I had this radical idea for a book called 7 Languages in 7 Weeks. It's just preposterous, right? But I talked it over with Dave. Dave loved the idea, and he said, well, we can actually poll our readers, and we could find out which languages that people were most excited to see. And this is the list that we came up with. Actually, it's not the complete list we came up with. We struck all the object-oriented languages on the list except one. And I knew Ruby well, so I wanted to write about that, so I wouldn't have to spend all my time in Ruby because I understood that family of languages well. I picked a prototype language because it nudged the reader a little bit closer to functional programming. I didn't want JavaScript because JavaScript's programming model is a little bit too rich. The behavior is a little bit too impure. So I picked a language called I/O, which had a very small number of constructs. Then I picked Prolog because it was a declarative language. And then a bunch of functional languages. And I struggled and, this book dragged me kicking and screaming into the world of functional programming. And I want you to notice 3 of the languages on that list: Ruby, ERLANG, and Clojure. So there's a guy in the Ruby community named José Valim, the creator of Elixir, that he was instrumental in the creation of the security model in the Rails platform, and he was also instrumental in binding the Ruby language to the web server. And José was reading this book and starting to feel the same itch that I was feeling, that object-oriented languages couldn't last forever, that we needed to be thinking about what was down the road. And he liked these three languages more than the rest. He liked Ruby because of the syntax. He liked ERLANG because of the concurrency. And he liked Closure because of its ability to have a concise, clean way of metaprogramming. So I stalked this guy and his language all the way to London. And I had a paper that he'd written, and was shaking hands. I kind of walked up to him and said, could you sign my paper, please? And he said, "You're Bruce Tate." And so he said, "Wait a minute." And he turns and runs off. And so I thought, oh man, I've really blown it now. And he comes back with a copy of 7 Languages in 7 Weeks. And he said, "This is part of what inspired me to write the Elixir programming language." I thought, wow, that's a really cool experience. And so José and I started to meet with Dave Thomas, and we started talking about what we would need to do to help launch this Elixir programming language. So I wrote 7 more languages in 7 weeks, and in that book, we came up with this list of languages. The 2 that I was most interested in were Elm and Elixir. Elm because of the same set of problems on the client side. That JavaScript probably wouldn't be enough for the next generation of applications that we had to build. And then I started looking around, and I recognized that Dave had beat me to the punch again, and that his nose was kicked into overdrive. So right before my book came out, his book came out, and it was called Programming Elixir, and people started to notice. And this last year, I got a chance to ask, Dave, what was it? How did you beat me to the punch? How did you find this language before I did? What did you see in this language before there was even a web server or anything that useful in the language? What did you see that made it so attractive to you? And he started telling me about QWAN. He said, functional programming without any kind of sugar is ugly. It's not the way we think. It's not the way we process things. But in Elixir, we have this concept called pipelines. And the pipelines really made functional programming click more than any other concept that I've seen. What it means is that everything on the left returns a value, and it's piped in as the first argument to the thing on the right. So you can build a program the same way that you pipe Unix operations. A very cool concept that not only changes the way that we think, but it changes the way that we compose things and the way that we layer our software. In fact, if you've read any piece of the Phoenix book, you could actually see that the pipeline has become a tremendous part of the way that we think about before filters, and really the whole flow of control through the Phoenix web server. And the nice thing about Elixir is that it's open for the whole community to develop, because Elixir is actually bootstrapped in the language itself. There's a tremendous macro system so that all these keywords, including the core ones, the def module, all of these are macros. Even the exception management, these are macros that are implemented in the Elixir language itself. And there's more QWAN. When you build an Elixir application, there's tremendous support for building beautiful documentation with it. And this documentation creeps into everything that you do in Elixir. For example, you could write these tiny little tests that are actually called doc tests, so that you have live Elixir code that actually runs as part of your application. And it actually creeps into the live terminal that you can use to build Elixir. And there's more QWAN. There was this idea of leverage, that you could take this program that every ERLANG developer has written, 128 lines of code, or 128 lines, and you can represent it with a single line of Elixir using macros. That's QWAN. And it goes on and on. So there's a brilliant testing platform so that tests are not only beautiful and consistent, but they're also concurrent. There's a protocol system so that I can code to interfaces instead of behaviors. There's great support for the production environment in mix and hex so that I could do things that I would do in Java with similar tools. And these happened right out of the gate. But the people were just fantastic. So this February, I got a chance to come to Krakow, and I got a chance to see your beautiful cathedral. And anybody who's been to this cathedral recognizes something. Maybe you didn't know the word for it, but QWAN is two-way. When you're inspired, it can inspire you. So pipelines are more than just a little bit of sugar. They're more than just beauty in the language. They inspire us to write software that's layered in the right way. Behaviors and macros inspire us to code to the right thing rather than coding to the implementation. We're coding to the implementation, not the we're coding to the domain, not the implementation. The great documentation tools change the way that we behave. We begin to write better documentation. We begin to become more complete programmers. And the modularity and the remote Elixir inspire us to write smaller apps that are more distributed and deploy them. We didn't call them microservices, but that's effectively what they were. And the great leaders in this space encouraged us to emulate them. So, we're finally getting to the point of the talk that this is difficult. This is hard. So Mount Everest is obviously the tallest mountain in the world. It's so high that the jet stream hits it, and the plume that you see coming off of the top is actually the wind from the jet stream blowing some of the snow off the top. It was first summited by the guy on the right-hand side, Sir Edmund Hillary, and by his lead Sherpa, Tenzing Norgay. And as I was looking at this picture, it struck me that there's a great metaphor between climbing a mountain and building a language. Because effectively, language making is seeking QWAN. It's hard because you're seeking qualities that can't necessarily be named. A language is more than just rolling up a bunch of features. When Sir Mallory was asked, one of the many people to die on Mount Everest, when he was asked, why do you want to climb Mount Everest? Does anybody remember what he said? That's right, because it's there. So he was seeking QWAN too. He was seeking this quality which could not be named, the same way that José was seeking this quality that couldn't be named. Everest has this death zone, this place over 8,000 feet, where every second that you spend in the death zone, the mountain is trying to kill you. There's not enough air. The ice is a little bit harder because it's a little colder. Your body's a little colder. And so the mountain is actively trying to kill you. So language making is difficult. So you're not just building when you're climbing a mountain like Everest, you're not just building a small, tiny team to zoom straight to the top. Typically, you're building a massive team to lay siege to the mountain so that you can establish these base camps and bring up the food and bring up base camps at higher and higher levels until you finally are in a position to make it to the top. For those of you who have followed Everest, you've probably seen that the mountain over the years has become progressively more and more trashed, as people that come up leave more than they take away. So language making, too, is sometimes messy. When I was here in February, I asked José, hey, what is it that makes you the most productive? And he actually answered that question in a way that I didn't quite expect. He said, I'd rather tell you, I have all the tools that I need to succeed. I have great people around me. I'm smart enough to solve the problems that are right in front of this language. The thing that's difficult for me is people. When people are angry and rude and impatient, it brings me down and makes me far less productive. And I thought about that, and it struck me, yeah, that's really true. And then I asked myself, why would anybody sign up to climb this mountain? Why would anybody subject themselves to this? How could you do it at all? Well, José's answer was, the community can get me to the top. We use Sherpas. So for those of you who don't know, the Sherpa is the community of people that live on the border between Nepal and Tibet. And they could do things at 14,000 feet where their communities are that we'd be hard-pressed to do at sea level. And Sherpas do a lot of things for a team on the mountain. On Mount Everest, you never go straight to the top in one straight line. You establish higher and higher camps. So you go up the mountain to acclimate yourself, and you go down the mountain to recover. And typically, there's a base camp and 4 other intermediate camps. And the Sherpas are the ones that make the base camps. So effectively, the Sherpas are doing the climbing to get the less deserving people to the top. And in fact, that's what happened with the Elixir language. Elixir is based on an ecosystem with the language called ERLANG, and there's a virtual machine, much like Java's virtual machine, that's called the Beam. And initially, when José was building the language, he built it such that Elixir could stand on its own. He called the language Lego, and he wanted to build all the blocks himself so that they would fit together in just such a way. And you see this commit tree, and you see a little gap in the middle here. So if you ask José, he calls this gap the Valley of Despair, because he knew that his approach wasn't going to work. Then he took one more attempt, code. He said, nope, it's really broken. This is a dead language. Then he made a decision to base Elixir on near-perfect compatibility with ERLANG, and to actually stand on the shoulders of the giants that had come before him. So he was actually saying, I'm going to let Joe Armstrong and Robert Verding and the rest of the ERLANG team, they're going to be my Sherpas that establish the base camp. I love this picture. You can picture the conversation in the back room, Hey, go carry the kitchen up to base camp. The whole kitchen? We got to take our water up. We got to take the chimney. That's cast iron. We got to take the stove. That's cast iron too. That's going to take at least 2 people, right? But the Sherpas carried the heaviest load. I can remember a time when I had told my boss that I wanted to bet the business on Elixir. He said, that's great. So what database system are you going to use? And I told him, and he said, what web server are you going to use? And I said, there isn't one yet. He said, what? I said, don't worry, we'll figure it out. And then I ran to call José and said, hey, we have to figure this web server thing out. You see, José was trying to build the language and the web server at the same time. That's a near impossible task. And what we started to do was as I talked about in the keynote, we said, you can't build a web server and a language at the same time. We're gonna table the old web server called Dynamo. We're gonna look at the best of breed, and on the Java ecosystem, there's the Closure language, and the Closure language has this abstraction called ring, where the functional layers of a web application are expressed with a tiny, simple abstraction. And we mirrored that, and we called that abstraction plug. And so basically, if you ask us what we were doing then, we were actually going fishing. We were fishing for Sherpas. And we caught a guy named Chris McCord. Chris had been writing a book called Metaprogramming in Elixir. And a lot of Ruby people love the way Ruby metaprogramming feels. And many of those same people like the way that the metaprogramming in Closure feels even better. And they like combining that metaprogramming system with the language, the syntax that's beautiful like Ruby's. And so Elixir gives him both of those things. But Chris was one of those people, and he had already started building something that looked a little like Rails, but acted like something very, very different, something much more scalable. So I remember a couple of years ago, we were sitting at the ERLANG factory in San Francisco, and Jose and Chris and I had a conversation, and we said, yeah, we're going to do this together. We're going to build a web server, and Chris was going to take the lead. We caught our Sherpa. This is the Kimbu icefall. This is one of the most critical, most difficult obstacles in the path up Mount Everest. And one of the reasons that it's so difficult is that you have to pass this icefall so many different times as you're climbing up the mountain. It's between two of the base camps, and it's actually right between the point where the most frequent traverses happen to be. And this was a very difficult thing, or this is a very difficult thing in any season. In the earliest seasons, each team of Sherpas, for each team that wanted to go up Everest, would have to plan their path up the ice fall at the same time. These days, what happens is some of the best Sherpas from all the team get together, and they weave these aluminum extension ladders together with these ropes and carabiners and ice stakes. And they weave this path through the Kimbu icefall. You see, the Sherpas prepare the way. So last year, there's a programming language called Elm, one that I'm excited about. And we had the Phoenix web server, and we recognized that those two technologies should work together, but they didn't. We needed a couple of Sherpas to prepare the way. So Evan Chiplicki and Chris McCord got together, and they decided how to make these technologies work together. So these are all examples of how Sherpas across the industry have helped Jose build an excellent programming language. You might say, Bruce, this makes me really uncomfortable. You're talking about climbing a mountain on the back of an oppressed people. So why, again, is this a good idea? But listen to me clearly. That's not what I'm saying. What I'm saying is this. We're all Sherpas. Every single one of us. We all have our mountains to climb. Mine might be Elixir. Yours might be Java or Scala or JavaScript. Every single one of us can make a significant impact into the ecosystems where we play, where we work. Every single one of us will benefit. And the things that we do in our ecosystem will impact significantly the people that come behind us. The least of us can do something. We can write documentation. We can encourage. We can write a talk. And the greatest of us can do something. We can put on a conference. We can write an open source framework. We can write a book. When we solve a problem, we can post the results to Stack Exchange, or even post the solutions to GitHub. But we're all Sherpas. And we can share the load, not because we have to, but because we're blessed. Any questions? Thank you.